Morning, everyone. I am Uma Maheshwari, VP Department, RMD Engineering College. This video, I am going to discuss about the subject High Voltage Engineering, and the subject code is E870. And the topic of this video discussion is about the protection against over voltages. So, what are the types of faults in over voltage and what are the causes of over voltages? So, the types of faults are symmetrical faults, that is three-phase fault, three line to ground fault, and unsymmetrical fault, that is line to ground fault, line to line fault, and double line to ground fault. Now, the protection of this equipments, power system equipments from over voltages due to lightning can be done by these methods. That is using ground wires above the phase wires and using ground rods, using counterpoise wires, using protective devices like rod gap, expulsion type, and whirl type surges. So the protection of the transmission lines against over voltages can be done by these methods. I'm repeating, it is the shielding of the overhead lines by using ground wires and above the phase wires. And the next method is using ground rods or counterpoise wires. And then we are using protection devices like rod gaps, surge diverters, and the line termination at the line terminations and substations. So what is ground wire? So the ground wire, it is a conductor which runs parallel to the main wire or main conductor of the transmission line and is supported on the same tower and earthed at every equal and regularly spaced towers. So the different arrangement of the ground wire you can see in the diagram. This is a earth wire or ground wire which is placed over the towers. And what are the important considerations of the ground wires? So the important consideration is the ground wire. The selection should be based upon the mechanical considerations rather than the electrical considerations. And it should have a high strength, electric strength, and it should be non-corrosive. And the ground resistance and the insulation and clearance between the ground wire and the lines are important when we are designing the ground wires. So this is a diagram of ground wire on the tower, electric tower. Now, the third point in this protection of the equipment is protection devices using the like say, expulsion gaps, protected tubes, and surge diverters. What is surge diverters? So surge diverters are the protection equipments which is used to protect the power system equipments from over voltages caused due to external over voltages and also internal over voltages. So what are the protection surge diverters or surge arrestor? The types are rod arrestor, on-gap arrestor, multi-gap arrestor, expulsion type arrestor, metal oxide type arresters. Now in this, we will see about the rod gap arrestor in detail. This is the diagram of the rod gap arresters. You can see in this diagram, the rod gap arrestor, there are two plates connected. The upper plate is connected to the transmission line which is to be protected and the lower plate is connected to the earth. Between these two rod gaps, a rod gap is there. So this is a diagram of rod gap on an insulating string. So it is used to protect the system from lightning or thunderstorm activity when the thunderstorm voltage is lesser value. And it is a very simple type of diverter. It consists of 1.5 centimeter rods, which is bent at right angles and with a gap between them, as it is shown in this diagram. Now, one rod is connected to the line circuit and other rod is connected to the earth. Under normal operating condition, this gap remains non-conductive. That is when the voltage is lower and it is not harmful to the apparatus carrying the voltage. Then under this normal condition, the rod, there is no spark between the gap in the rods. Whereas due to any electrical higher voltage surges, that is maybe due to the lightning strokes or the opening of the circuit breakers, a high voltage surge occurs on the lines and the spark occurs across the gap, and the surge current is conducted to the earth, to the to the earth with the help of this rod gap connector in the lower part. So in this way, the excess charges on the line, it is conducted to the earth without affecting the electrical equipments connected to the transmission line. So now we'll see what are the advantages of this rod gap arrestor. This rod gap arrestor, it is simple in construction and it is cheap. And what about the limitations? These rod gap arrestors get melt or get damaged due to excessive heat produced by the arc. And with various climatic conditions, such as rain, humidity, and temperature, it affects the performance of the rod gap arrestor. Now, the polarity of the surge also affects the performance of the rod gap arrestor. This rod gap arrestor is mainly used for low value of spikes. That is, because of the above limitation, it is only used as backup protection in case of the main arresters. Now, for this rod gap arrestor, in order to protect the equipments, the distance between the rod gap and the insulator should be 1/3 of the rod gap length. If the system voltage is 33, then the rod gap length should be 225 millimeter. And if it is 66, the rod gap distance should be 350 millimeter. And if it is 132 voltage, the rod gap length should distance between them should be 650 millimeter. And if the system voltage is around 275, the distance between the two rod gaps should be around 1230 millimeter. The limitations of this rod gap. So the difficulty of this rod gap arrestor is that once the spark is taking place, it will continue for some time. And even when the supply voltage is returned back to the normal value. Okay, this should be avoided in order to protect the equipment. And this rod gap arrestor gets damaged due to high temperature of the arc, and this causes the rods to melt. And this performance of this rod gap is affected by the climatic variations and also depending upon the polarity of the surges. So this video, we have seen what are the protection devices used against low voltages, mainly the rod gap arrestor. Thank you, everyone.